Does anybody remember?
Radical?
Uh-huh.
Like a decimal?
It's not decimal. It's that symbol right there, right?
Oh,
If I'm taking a square root of something.
Yeah, you like a number, you square root it and
Uh-huh.
divide it pretty much.
So that's...
Yeah.
So what a square root does is it says what number times itself gives me the number underneath. It's like if I was taking the square root of 16, that is asking what number, when I multiply it by itself, gives a value of 16.
4. Well, no,
Be 4, right? 4 times 4 is 16. So the square root of 16 is 4. What we're going to have today, we're going to have some square roots that are not so pretty. Like what if I ask you, what's the square root of 10? So what number times itself is 10?
Well, yeah. 3.1.
Nothing.
There's no great number for it, right? It's going to be an irrational number. So we're going to be looking at things like this, square roots of 10, and asked to find the simplified form. So here's our first question. It says, what is the simplified form of the square root of 20? So first I'm going to show you how to do this if you did not have a calculator. I'm going to show you how to do it if you didn't have a calculator first. Okay? And then we'll put it in our calculator. Make sure y'all know how to do that. Okay? So if I have the square root of 20, that means I'm saying what number times itself is 20? Well, 5 times 5 is 25. That's not times itself. Right? So to take the square root of something and get 20, it's not a pretty number. It's not one of our 1, 2, 3, 4, 5. Right? It's going to be something that's ugly. So how we simplify this is we list what's called our perfect squares. So a perfect square are the numbers that you get when you multiply two whole numbers together. So here's how you get a list of perfect squares. 1 times 1 is 1.
Oh, sorry.
That's fine. And that's pretty much the most useless perfect square. Okay, if there's one that's useless, that's the one you don't like yet. The next one, 2 times 2.
4.
3 times 3.
6. 9.
9. 4 times 4.
16.
5 times 5.
25.
6 times 6.
36.
7 times 7. 49. 8 times 8. 64. 9 times 9.
81.
81. 10 times 10. 100. 11 times 11.
121.
12 times 12.
224.
That's good enough. We can stop there. Next one is 169. 196. 225. 256. Represent. Yes, that's where I'm from. Yes, sir. 16 times 16. Okay. But right here's the first 12 perfect squares. So if I had to simplify the square root of 20, I know that it doesn't work out perfectly. It's not one of these numbers. But I look, can I rewrite 20 as one of these times another number? So can I do 20 as 16 times a number?
No.
What about 9 times a number?
No.
What about 4 times a number?
Yes.
Yes. So what we do then is we take the square root of 20 and we're going to rewrite it as 4 times 5 underneath there. Now when we do that, when it's broken apart by multiplication, that means I can simplify one of these factors. So what is the square root of 4? What number times itself is 4? 2. So we can bring 2 out front. The 4 inside the radical becomes a 2 out front. And then what about the square root of 5? Does that work out perfectly?
Yeah. No.
It doesn't. Can I use one of these numbers to rewrite 5?
No.
You said 5.
Huh?
Each row is 5.
Right. So we leave it underneath there because it doesn't work with one of these other numbers. So we bring the 2 out front because the square root of 4 is 2. And square root of 5 does not work out. And it doesn't have any of these that we like because we don't care about 1. 1's useless. So it has to stay inside. Can't come out of the radical. Now, if you put square root of 20 in your calculator, you should see it simplify to this. 2 square root of 5. If you can't get that to work in your calculator, let me know. But I want you to do that right now. Practice.
35.
Okay, and how do we say that?
9 times 5 equals 45. You get 5.
Right, so we can rewrite 45 as 9 times 5. The square root of 9 is 3. The 5 is stuck. So this is said 3 radical 5, or 3 times the square root of 5. You can say it either way. Then B part, the square root of 50. How did it simplify?
5.
All right, so it would be 25 times 20, or times 2, right? No, he's saying the final answer. But he just says 5, 2, instead of saying 5 radical 2, or 5 times the square root of 2. All right, that's how you need to say it. Let's first do this without a calculator. Let's use our calculator to check our answer. So this is telling me to multiply square root of 18 times square root of 2. Notice how both of these have numbers that are already underneath the square root. So I can just multiply them together. So the square root of 18 times the square root of 2 is the same thing as the square root of 18 times 2, which is 36. And so then what number times itself is 36? 6. So we should just get a value of 6. Again, you could plug all this into your calculator, radical 18 times radical 2, and you should get the same thing, which is 6. A part. What'd you get as your answer? 12? What do you guys think?
Yes.
That is correct. Any questions there? 48 times 3 is 144. And the square root of 144 is just 12. Very good. Pick a number, 2 through 5. It's 4. Pick a number, 1 through 2. It's 2. B part. You haven't done it yet? Well, ask if we were ready. 27 times 12. What did we get?
334.
You got what?
324.
324, and you multiply those together? And then the square root of 324 is 18? Differently. So this is what I want us to look at. Square root of 96. Is that a nice one? No, it's not. Square root of 54. Is that a nice one? No, it's not. So I need to look for perfect squares that I can work to be in here. It's like, again, my list of perfect squares. 1, 4, 9, 16, 25, 36, 49. That should be long enough list for here. So like 96, can I write that as 49 times a number? No. What about, can I do it as 36 times a number?
No. No.
No. 25 times a number? No. 16 times a number? Yes. 96 is what? It is 16 times 6. Okay? Now let's do the same thing with 54. So which one of these will work for 54? Does 36 work? No. 25? No. 16? No. 9?
Yes.
Yes.
Times 6.
9 times 6 is 54. Okay, so remember, what happens when you used to divide numbers in a fraction like this? Like, what if I had, have y'all done stuff like this, like x squared divided by x? Okay, what if you had,
Wait, when you did
hold on.
x squared divided by x, I think I might have did that in the Sanders.
What about simplifying a fraction like 4 divided by 8? Guys, I don't know why you're talking.
Yes.
Simplifying a fraction, 4 over 8. What does that simplify to be? 1/2. So the way that you used to learn that is, okay, well 4 I could write that as 4 times 1. 8 I could write as 4 times 2. And because they both shared a 4, the 4's cancel on top and bottom, which leaves you with a half.
I never did it that way.
Well, that's how you're supposed to simplify fractions. So the reason I bring that up is look here on top and bottom of my fraction. They both share a times 6, right? So I can cancel the 6's out, which leaves this as the square root of 16 over the square root of 9. Well, what is the square root of 16?
4.
The square root of 9.
3.
So it's 4/3.
Whoa.
All right. Pick a number, 1 to 5. 2.
Bro, it's always 2.
And I should have just been 2 to 5. Okay, we only got one person on the second row. Hasn't been. Yes? Yes? Okay, what'd you get on A? 5/2. What do you guys think?
Yes, sir.
That is correct. We could simplify that to be 25 times 3, and this to be 4 times 3. And so that would give me those radical 3's cancel on top and bottom. So I'm left with the square root of 25, which is 5, and the square root of 4, which is 2. Very good. Pick a number, 2. Pick a number, 3 through 5. It's 3. Pick a number, 1 through 2. It's 2. B part. 4/5. What do you guys think? Again, that is correct. We just did the square root of 96. We could rewrite that to be 16 times 6. And the square root of 150, that is 25 times 6. So the square roots of 6 cancel. And I'm left with the square root of 16, which is 4, over the square root of 25, which is 5. So now we're going to be simplifying radicals, but there's going to be addition and subtraction between them. Okay? So I have 2 radical 3 plus radical 3 plus 5 radical 15 minus radical 15.
We just add all those together?
The calculator did it for you. We need to make sure we.
The calculator will do it for you.
No, I'm just saying, can we add all of those?
Okay, so this is how you do it. This is how you do it. Yeah, like terms. You combine them like terms. So first, make sure that what you have underneath the radicals will not simplify. So radical 3 definitely will not simplify. Okay, what about radical 15?
Yes.
What will that simplify to be?
5.
We could write 15 as 5 times 3. Are either one of those perfect squares?
No.
They're not. And then the only other option is 1 times 15. So radical 15 does not simplify. So we leave it all just like it is. Now we're going to combine like terms. So since this one has a radical 3 and this one has a radical 3, we combine them. So if I have 2 radical 3's and I add a radical 3, I now have 3 radical 3's. Okay? The radical, whatever's under the radical is basically like a variable. You know, like if you did 2x plus an x, that's 3 x's. So 2 radical 3 plus a radical 3 means I have 3 radical 3's.
So you're saying there's like.
There's an understood 1
Yeah.
in front of the radical. Yes. Yeah, very much just like a variable works. Okay, so now 5 radical 15 minus radical 15. What do you guys think that is?
15. Or 4/15.
It's going to be 4 radical 15. Because I had 5 radical 15s and I subtracted one of them. So now I have 4 radical 15s. So now I have 3 radical 5 plus 2 radical 20. So first things first, make sure that they don't simplify. Radical 5 doesn't simplify. Radical 20, what could we rewrite 20 to be? It could be 4 times 5, right? And 4 is a perfect square, so I could bring it out front. So let's think about just that part. So 2 radical 20 is the same thing as 2 radical 4 times 5. Now, what is the square root of 4? It's 2. So now I have 2 times 2 radical 5. And 2 times 2 is 4 radical 5. Everybody see how all that works out? But sure, no questions? Now, the 3 radical 5 is left over, so I can bring it down. So now I have 3 radical 5s plus 4 radical 5s. That's going to combine to give me 7 radical 5s. Should I just take it from him? Does he ever do anything without his phone? Nothing? What are my like terms? Right, the ones that have radical 5s are alike. So if I have 11 radical 5s and I subtract 4 radical 5s, we just have to basically do 11 minus 4. Okay, and then is there anything like 4 radical 7? No, so it stays the same. So I get 4 radical 7 plus 7 radical 5. Final answer.
Yeah, I was stuck right after that.
Yep, those two don't combine, and that's it. You're done. Pick a number, 3 through 5. It's 5. Pick a number, 1 through 3. It's 1. All right, what's the first thing we need to look for on this one? Right. Well, I have none that already match, right? So I have to see, can I simplify the radicals? So like the square root of 8, will that rewrite?
Yes.
Yes. What could I rewrite that as?
2.4. Or 2, 4.
Right. It's going to end up being 2 radical 2, right? But let's just say that the square root of 8 is 4 times 2 underneath it. And we'll fix it all later in a second. What about radical 2? Will that simplify?
Yes. No.
It does not. All I can rewrite 2 as is 2 times 1, which is not going to be helpful. Right? Remember, 1 is useless, so forget 1. And then there's nothing else that'll work for 2. And then 18, what could I rewrite that as? 9 times 2, and 9 is a perfect square. So that works out well. So now we said the square root of 4 is 2, right? So 2 times 2 is going to give me 4 radical 2 there. We said 6 radical 2 would not simplify. And if I pull the 9 out front here, it becomes a 3. So now I have 4 radical 2 plus 6 radical 2 minus 3 radical 2. Now they are all like terms. They all have a radical 2. So 4 plus 6 is 10. 10 minus 3 is 7. So 7 radical 2 is my final answer there.